morning, guys. So the other day we worked with angle bisectors, right? And whenever you're dealing with a bisector always cuts any figure in half, right? What we're going to work with today is something that's called perpendicular bisectors. And again, it seems more complicated, but we're still working with principles of bisectors, right? And whenever you're dealing with any type of bisector, always realize that a bisector is always going to cut any figure in half, right? Always going to make it two equal parts. So when we have angle bisector cut an angle in half. What a perpendicular bisector does, not only is it going to cut a segment in half, but now it's going to form perpendicular lines, right? They're two different things. One, bisector means it's going to cut something in half, a segment. The perpendicular means that it's going to create perpendicular lines, right? And so what perpendicular lines are lines that literally intersect, right? And they make a right angle, right? That's what perpendicular means. Perpendicular literally means that whenever you have two perpendicular lines, they intersect to make right angles. So when you see that, perpendicular part is going to give us segments or lines that are going to intersect to make right angles. And then the bisector part's just going to tell us that it's going to be cut in half, right? So what a perpendicular bisector is and what it looks, I'll show you this way. Let's say you have a line, right? And we have a segment, just for purposes of it. We have this segment, right? And the way that we have a line that's cutting a segment, right? For it to be a bisector, we want this line to cut this segment in half, right? So in order for us to cut this in half, or in order for this to be a bisector, this has to be the same as that. Because again, if this line is cutting this in half, it means that that's going to be the same as that. The way we show that, we can put a tick mark there, and we put a tick mark there, right? Because now, the way we see it, if this is congruent to that, if this segment is congruent to that segment, then this cut it in half, right? So that would be a bisector, right? Because this is cutting this segment in half, right? That's the bisector part, seeing that these two are the same. The perpendicular part now would be, if these lines are intersecting, perpendicular means that they have to form a right angle, right? And that's what a perpendicular bisector is. A perpendicular bisector says not only do they form right angles, right, when they intersect, but the bisector part says that it's equal because they're being cut in half. So perpendicular bisector always has to have two parts. These segments need to be congruent because they were cut in half. And it has to form a right angle because they're perpendicular lines, right? So when this happens, and again, it's just seeing that, when this happens, this perpendicular bisector occurs, we know that this line is in the middle, right? Any point's in the middle. So let's say I were to draw a point right there. And if this line is perfectly in the middle, because you have to think of it this way, when you have a right angle, it means that this line's going straight up, right? If it's perpendicular, the line that you draw is going straight, right? It's going perfectly up. And then, since that's in the middle, right? This line's in the middle, because since those two are the same, that's in the middle. If I were to draw a line there to the middle, and I were to draw this line here to the middle, almost think it. Since that's in the middle, and that's going perfectly to the middle, we know that this is going to end up being congruent to that automatically. And we know that those two are going to end up being congruent because it's the same idea, which is if these two are congruent, and this is forming a 90-degree angle, then automatically those two are going to be congruent always. Because again, if these are congruent, then it means that that's in the middle. And if that's in the middle, those two have to be the same because they're going to the middle. And they're going straight, right? So always remember, when it comes to a perpendicular bisector, if these two are congruent, then automatically these two are congruent. The opposite's also true. If these two are congruent and we have a right angle, then automatically these two segments are congruent. It's always the idea of a perpendicular bisector. And the way that it looks is this way. Basically always seen, right? If I were to show you, for example, that again, we have a line, right? We have a segment. Right? I'm going to put a tick mark here and a tick mark there to show if they're the same. I'll put a right angle there, right? So basically, if I were to say that this is 8 inches, right? Automatically, if that's 8 inches, then we know that that's 8 inches, right? And if those two are the same, if this now is 10 inches, this one has to be 10 inches. Because the idea of a perpendicular bisector says if these two are congruent and there's a right angle showing it goes straight, then automatically these two are congruent. Always. Opposite way is true too. Let's say that we had something like this, right? And it's always just applying that idea, right? Which is, if now, for example, same idea, right? And I keep drawing it just to get you guys comfortable with it. If we have that, right? Again, we have a right angle to show that it's perpendicular. I want to make this congruent to that to show that it's a bisector in the middle. Now, I'm sorry, I didn't want to draw that. I wanted to draw this. I apologize for that. Now, it's the opposite idea, right? If these two are the same, let's say that that's 6, now that's 6. If those two are the same and that's a right angle, now automatically these two are always going to be the same. It's just that idea. It goes back and forward, backwards and forward, right? If these two segments are congruent and that's a right angle, then these two are congruent. If these two are congruent, then automatically those two are congruent. And it all hinges on the idea that that has to be a right angle, just because that right angle tells you that that is going straight, right? That's what it looks like. Now, the way that we actually use it to solve equations, it's nothing harder than that. It's what you guys have been comfortable working, setting up equations to be able to solve for it, right? Let's say that we have this, right? We have this right there. Make that congruent to that. And I want to have that as right angle. So we have a perpendicular bisector. Perpendicular is right angle, bisector are those two points, right? I'm going to give you that, I'm going to give you that. Now let's say that this side here is going to end up being 2m plus 8, right? And let's make this side here 20, right? Let's say I want to solve for m. So this segment here is 2m plus 8. This segment there is 20. If I want to solve this, again, we know if these two are congruent and that's a right angle, then property of perpendicular bisector says that those two are going to be the same, right? If these are the same, those two are the same. They're congruent. And if those two are congruent, we can just write an equation to show that, right? Because if they're congruent, it means they're equal. So if they're equal, we know that 2m plus 8 equals 20. Because we know that the 2m plus 8 equals the 20. And once you have that equation, now it's just solving it out, right? We have 2m plus 8 equals 20. Save the variable for last, right? To get rid of the 8, we do the opposite of addition, which is subtraction. Subtract from both sides. And we're left with 2m equals 12, right? Because 20 minus 8 gives us 12. Now to solve for m, again, we have to get rid of the 2. The way that you get rid of the 2 is do the opposite. When you have it next to the variable, it's multiplication. Opposite of multiplication is division. Divide that by 2. Divide this by 2. Cancels out. And we're left with n equals 6. And again, we get 6 because 12 divided by 2 gives us 6, right? And if you wanted to check your answer, you could. Because we know that m is here, right? So if we wanted to substitute m for 6, 2 times 6 is 12. 12 plus 8 is 20. They're both the same. Which lets us know that they're right? And it's that idea of a perpendicular bisector, guys. When you set up an equation to solve, it's just applying that idea to write out the equation. Let's just try out one more just to get you guys comfortable with it, to see it. Let's say that I gave you 10. It's all the same. Sometimes it looks a little bit different the way it's drawn, but it's always the same information, guys. You have a segment, right? We have a line right there. We have a right angle, which again tells us that it's going straight. We have this here, we have this there, right? And I'm going to say that that's congruent. I'm going to say that that's congruent, right? So we have that. And now let me write this. Let's say that this segment here is going to end up being, let's make it 6f minus 10, right? So this here is 6f minus 10. Let's make this one here 3f plus 2, right? So we know that this here is 6f minus 10. We know that this here is 3f plus 2. And we want to solve for f, right? If we want to solve for f, let's think of it this way. We know that that's a right angle. We know that these two are the same. So if these two are the same, automatically those two are the same, right? And if they're both the same, we can write it out that way, right? We can write it out that 6f minus 10 equals 3f plus 2, right? And we know that they're equal because, again, right angle, and those two are congruent, so automatically these two are congruent. And if they're congruent, we just set them equal to each other. 6f minus 10 equals 3f plus 2. And once you get this, again, always learn the trick. Get rid of the smallest variable. Smallest variable here would be the 3f. 3f is positive. Opposite of a positive is a negative. 3f minus 3f, right? The 3f's cancel. 6f minus 3f gives us 3f minus 10 equals 2. Okay? Now again, you want to get f by itself. Let's get rid of that 10. Opposite of subtraction is addition. Add 10 to both sides. We have 3f equals 12 because 2 plus 10 gives us 12. And now we have 3f equals 12. To get f by itself, to isolate f, we want to get rid of the 3. Opposite of multiplication when they're next to each other is division. Divide both sides by 3. The 3's cancel. We have f equals 12 divided by 3 gives us 4. And there you have it. Again, it's just getting comfortable with writing it out and seeing it, right? And whenever two segments are congruent and you have a right angle to show that it's straight, automatically the other two are congruent always, right? And since they're equal, we set them equal to solve it, right? Now what we're saying is f equals 4, right? Because now if we wanted to, let's say I wanted to find the length of each of these segments, right? We know that they're both the same. So it doesn't matter. We could use this one. We can use that one. That doesn't matter, right? I say you always go with the easiest one if you need to figure out the length. We know that the easiest one to work with looks like 3f plus 2, right? So if I wanted to figure out how long this is, let's say, right? We have 3f plus 2. And again, this is me just checking to see how long that is. We can do 3 times 4 plus 2, right? Because f is 4, so we just substituted. We know that 3 times 4 is 12, plus 2 gives us 14. So if anybody ever asked, we would know that that's 14. And automatically, without doing any work, if this is 14, we automatically know that this one's also going to be 14. Because again, we said they're congruent. And if you wanted to check it, 6 times 4 is 24. 24 minus 10, 14. It's that idea, guys. Always feeling comfortable with substituting to figure out the lengths of it. But most important thing is always being able to write out the equation to be able to solve for the variable, right? But once you have that, everything else becomes a lot easier to work with. Just always remember, guys, perpendicular bisectors, not only do they cut a segment in half, but it has to form a right angle. And if you have any questions, feel free to ask. Take care.